Everyone, if you're new to the channel, you can subscribe to the channel for future updates. And guys, please visit my website, guys. You can check the link in the description below. And of course, I have launched the new Instagram account and make sure you follow for more future updates. Enjoy the solutions.
Hello everyone, welcome to this Monbukagakusho Mathematics A 2016. And yeah, this is probably for the applicants who want to apply for the social science field. And yeah, let's continue to for this part 1. Okay, so part 1 in the question says that if we make a sequence selecting 3 elements from 3 different elements of uh, the elements of 1, 2, and 3, and they say the first case is we permit overlap elements for the sequence, then the total number of sequence is what? So that means that the overlap element is that in the 3 elements this form could happen. So 111, 112, 113 until 333, right? So the overlap elements in the sequence is, by total, there are 3 elements that could fill the first one, and 3 and 3. So that is, there are 27 elements for the overlap elements to be fulfilled. And the second case, if we do not take into account the order the total number of the selection is. So what's the case mean? The case means that if we do not take account the order, which means that if we actually make the numbers one by one again like this, so 111, 112, right, and then 113, then if we want to make 1 to 1, this is prohibited because there's 112, 1 to 1, so the same element. That is what we said, we do not take account the order, so this is cannot. 122 is possible because there is no element here that have number 2 and 1. Okay, 123 is possible, right? Then if 132 is the same element as this, so this is prohibited. Then 131 is the same as this, is prohibited too. And 133, then we move on to 211. It is prohibited because of the order. Then 212 is the same as this, so it cannot. And what about 213 is also prohibited, right? Then what about 221 is also prohibited. 222 is possible. 223, it's possible too, right? 223. Then 231 is prohibited. 232, 232, 232 is possible. 233, 233, I think it's possible too. Wait, 232 is prohibited because of 223, the same order of the element. 233 is cannot. Then 311 is same as this. 312 is same as this. Then 313 is the same of this. 321 same as that. 322 is the same as this. 323, this one. 331, this. 332, 332 is this, and 333. Now finally we have the total number of elements that we do not take account into the order is 1 2 3 4 5 6 7 8 9 10. So there are 10 elements if we do not take account the order. So you can see the answer there. The box 1 is 27 and box 1 2 is 10. Okay, so let's go on to number 2. For number 2, it says that in the two-dimensional surface, if we take the point 2.1, okay, at the center point, then consider that point to be a transformation with the rotation angle of 45 degrees. Okay, so it means that 2.1 is as the center point, and we're going to transform the point 3.3 by the rotation angle of 45 degrees. So what it meant is that when I draw a graph here, and let's say I want to draw the point 2.1, this is as the center point, okay, center point, the point of rotation. Then I want to transform the point 3.3 with the rotation angle of 45 degrees. So how to do that? The way to do it is, there's actually the formula for it. So for example, the result of that is into point, let's say point x point y. Okay, x point y is equal to cosine theta, the angle of the rotation, minus sine theta. Is actually formed into matrix sine theta, cosine theta, then the, let's say this is the point that we want to rotate, a point b. A, because we have a center point, we make that m point n, so that is a minus m, b minus n, plus mn. So this is the formula. If you have a point that you want to transform by the rotation angle of theta, then it is rotated with the center point of 2.1. But in the case of where you didn't have the center point, let's say the center point is the origin 0.0, the and also a rotation transformation, the formula is this one. Remember that this is a matrix and a b. Okay, so this is the resulting the result of the transformation. This is the angle of the rotation, and this is the point that you want to transform. Okay, so let's put the numbers in. So cosine 45 minus sine 45, sine 45, cosine 45, right? Then a is the 3 minus 2, then 3 minus 1 plus 2 and 1, right? So we calculate that as usual. Cosine 45 is half root 2, minus sine 45 is minus half root 2. This is half root 2 and half root 2. Then this is 1, 2 plus 2 and 1. Okay, so now we multiply the matrix. This times this is half root 2, and this times this is minus root 2, and this time that is half root 2, then plus this time this is plus root 2, and we plus with 2 and 1, right? So we got the result that if you added a matrix this, you add by that, the same line, the same row, you added it together, so that is 2 minus half root 2, and then 1 plus 3 over 2 root 2. Okay, so the answer, the result, that look at that, the point 3.3, when it is transformed with the center point of 2.1 with the angle of rotation of 45 degrees, it is resulted into 2 minus root 2 over 2, 1 plus 3 root 2 over 2, right? So if you didn't familiarize yourself with the formula of the transformation rotation, especially with this type of question, maybe you should just practice more question that it is available in the internet. You just can search it out. Okay, so that is the answer for number 2, this one, right? So let's go to number 3. For number 3, it is said the example of the graph of a cubical function. So y equals the box 1 4 x cubed plus 1 over 5 x squared 1 6 x plus 1 7. So this is just only the question, and they say that the graph of the cubical function goes through 0.1, minus 1 point minus 2, then 1.2, and 2.9. Okay, so to ease the calculation, we just turn that into variable ax cubed plus bx cubed plus cx plus d. Then you know that from this equation that to find the variable of a, b, c, and d, the constant, the value of the variable, you could just sub in all the coordinate. So let's say, so for 0.1, the y is 1 and the x is 0. So 0, 0, 0, and the rest is d. So d is 1, and now we have minus 1 point minus 2. If we make y is minus 2, it is equal to a, we put the minus 1 in, right, minus 1, so a minus 1 cubed plus b minus 1 squared plus c minus 1 plus d. So minus 2 is minus a plus b minus c plus 1, right? Remember d is 1, we already got that. So we put it there, minus 3 equals minus a minus plus b minus c. And if you want to ease, you just want to eliminate this, 3 equals a minus b plus c. So this is equation 1. And now you put this coordinate in just as that coordinate. So 2 equals a plus b plus c plus 1, right? So 1 equals a plus b plus c, equation 2, right? And then this coordinate, so 9 equals a times 2 to the power of 3, 8a, then plus 4b plus 2c plus 1. So 8 is 8a plus 4b plus 2c, and you can simplify this, divided by 2, right? 4 equals 4a plus 2b plus c, equation 3. Now we need to find the value of this constant. Remember that if you have 3 variables, you need exactly 3 equation that bears these 3 variables. That's what you only need, to solve that equation there. So we just need to eliminate this. So let's say we use equation 1 and equation 2. 3 is a minus b plus c, and 1 is a plus b plus c, right? So you can subtract that. 2 equals, this is cancel out, this is equals minus 2b, and this is cancel out too. So b is minus 1. Now you have b is minus 1. Let's say I use equation 2 and equation 3 to find the rest. Now I know that b is minus 1. So 1 equals a minus 1 plus c. So 2 equals a plus c. Then 4 equals 4a minus 2 plus c. So 6 is 4a plus c. I could subtract that. So minus 4 equals minus 3a. So a is 4 over 3. Now I know that a is 4 over 3. I could find c from this, right? So 2 equals 4 over 3 plus c. So c is 2 over 3. And now I got all 4 variables, the value of it. So the answer is, the cubical function of the question number 3 is y equals 4 over 3x cubed plus, minus 1x squared plus 2 over 3x plus 1. So that is the answer for number 3. And yeah, let's go to number 4. So now number 4 is actually a unique question here. We have absolute function. Okay, number 4. If a function fx with the domain of between side bracket 0, 2. What it means by side bracket is that this one, 0 and 2 inclusive. Okay, so that is the definition of side bracket. If you have curved bracket like this is meaning the same meaning with 0 less than 2, less than x less than 2. 0 and 2 is not inclusive. Okay, so now from the function that is given, the absolute of x minus 1 plus absolute of x squared minus 2x. Now they ask us what is the minimum value of that and what is the maximum value of that. So to do this equation, because that is the example of the absolute function, we need to examine this one by one, right? Because this is an absolute function. It's not just regular equation where you can just just throw this absolute sign away, then you do that. But no, you just have to analyze it one by one. The way to do that is when you have absolute function of x minus 1, right? And you have the interval, the domain is limited between 0 and 2, 0 and 2 inclusive. Now, we have the number line just to show you that when is x minus 1 is positive. X minus 1 is positive when the value is greater or equal to 1, right? So x minus 1 is positive, right, when the value is greater than 1. If you have value less than 1, like 0.9, it makes that negative, right? 0.8, then less, it is make. So for this positive, it needs x greater than 1. And now, for the value of the absolute function, the content of it, to be negative, it is x less than 1, right? I will show you what this means. And now, for the second function, x squared minus 2x. Now, the content of the absolute function, x squared minus 2x, is positive, right, when it has the value less than or equal to 0 and greater or equal to 2, right? For example, if we have minus 1, minus 1 squared is 1, minus 2 times minus 1 is 3, so that is positive. Same as this, if you have let's say 3, 9 minus 6 is 3, right? But the value of that will be negative if you have the interval of 0 less than x less than 2. Let's say 1. 1 minus 2 is minus 1, right? So that is the how to analyze this two absolute function. Okay, so now how to actually utilize this type of equation here. Now the domain has already limited to 0 and 2. So any number less than 0 and any number greater than 2 is do not use, right? We only focus on that particular interval. Okay, so at this particular interval, you can see that number 1 is also inside this interval. Okay, we divided this area into 2. This is area 1, this is area 2. Now, in this area 1, the value of x minus 1 is negative, right? Because it is x less than 1. Less than 1, the value of this is negative, right? And the value of x squared minus 2x is also negative. So for area 1, the fx is minus x plus 1 and minus x squared plus 2x. It is minus x squared plus x plus 1. And then for area 2, the content of x minus 1 is positive, right? And the content of x squared minus 2x still negative, right? So the area 2, the fx become this, fx minus 1 minus x squared plus 2x, x squared plus 3x minus 1. And now, believe it or not, these two functions bear the same maximum value. Now, so how to actually find the maximum value for the function? You just have to differentiate it. For example, this, we differentiate that minus 2x plus 1 and make that equal to 0. So x is half. Now, how we know How do we know that x equals half is the value that would make this fx maximum? The simple concept is that you differentiate it again. So double differentiation is minus 2. And remember, if double differentiation, okay, if it is less than 0, it means that it is maximum. Okay, so x is half. If we put it in the function again, so half minus 1 plus 1/4 minus 1, so that is half, right? Absolute function, if you have the contents negative, you make an absolute sign, it becomes positive. Plus 3/4 is 5/4. So this is the maximum value. Now what about this? We will just differentiate it again. Minus 2x plus 3 equals 0. X is 3/2. And even with this, we just substitute that with this function here. So that is 3/2 minus 1 plus 3/2 squared is 9/4 minus 3. So that is 1/2 plus this is minus 3/4, right? With an absolute sign, it becomes positive. Also 5/4. Okay, and now how to find the minimum value? The minimum value is when the area 1 fx is equal to area 2 fx. So minus x squared plus x plus 1 equals to minus x squared plus 3x minus 1. So we cancel that out. This is equals 2, 2x, and x equals 1. So if we substitute that to the original function, this one, that will become f equals, this is the original function, it is 0 plus 1 minus 2 plus 2, 1. Okay, so the maximum value for the absolute function is 5/4, and the minimum value is 1. So that is for number 4, right? Yeah, okay. That is for part 1 of Mathematics A 2016.